So let's take a look at these two. For the first one, if we wanted to start out with the numbers, 18 over 12 reduces to what? 3 over 2. Good. Both of them can divide by 6. So we get 3 over 2. So we know the numerical part of our result, our reduced fraction, is going to be 3 on top and 2 in the numerator, or in the denominator, sorry. What's going to happen with x? It'll be on bottom because the larger power is on bottom. What power are we going to have? Careful. Yep. So it'll be 6 because 8 minus 2 is 6. Where's the y going to go? Top, because the larger power is on top. We think of this as y to the 1, so that's going to be y to the 4th. So 3y to the 4th over 2x to the 6th. How many of you had that? You were most of the way there, right? Yeah. Close enough. For the numbers in this one, 35 over 40 is going to reduce to 7 over 8. Very good. How about x? Top, power of 6. Good. The larger power was on top. 8 minus 2 makes 6. How about y? Top, power of 1 or just y? Perfect. Because 3 minus 2 is 1 and the larger power was on top. Z? Bottom, power of 1 or just z? 3 minus 2 is 1. So it's z to the 1 or just z and the larger power is on bottom. So 7x to the 6th y over 8z. We're going to come back and do more with these later. For right now, I want to review. We had talked about multiples. A multiple is just taking a number. Let's say we start with the number 7. The multiples of 7. Well, 7 itself is 7 times 1. The next multiple would be 7 times 2, which is 14. The next multiple will be 7 times 3, which is 21. 7 times 4 would be 28. 7 times 5, 35, and so on. And you can see all we're doing is counting up by 7s. So if I wanted to list the multiples of 5, of course 5 itself is 5 times 1. The next one would be 5 times 2, which is 10. 5 times 3 is 15. We've all counted up by 5s enough that we don't have to do the multiplication. It'll be 15, then it would be 20, 25, 30, 35, and on up. So if we're just dealing with the numbers, the multiples are relatively straightforward. If I have 4x squared, well, this is 4x times 1. Well, or 4x squared times 1 would 4x squared times 2 be? 8x squared. 4x squared times 3, 12x squared, and so on. When we throw in the variables, however, the pure multiples here, just the numerical multiples, because the multiples are just defined as that, times 1, times 2, times 3, times 4, and on up. They don't tell the whole story. We can also multiply the variables by variables and get other versions of multiples. So anyway, for now, I want to then jump from just the flat out multiples to common multiples. And we talked about this a little bit before. The idea of least common multiples. LCM is what it's going to be called from now on. If I have 8 and 6 and I want to find the least common multiples, what did we do? I mean, we could just list out the multiples, but we had a process using our factoring. You remember what it is? If I factor 8, what do I get? 2 times 2 times 2. If I factor 6, I get 2 times 3. And when I'm looking for, if I was looking for a greatest common factor, I would take the factors that were in common and that would be it. But I'm not. I'm looking for least common multiple. I start out the same way. I still, number one, I look for common factors. And in this case, there's only the one. There's a 2 in each of them. The second thing I do then is I have to make the others common, or I have to put in the missing ones, missing factors. And how I know which factors are missing is I compare them to each other. This top one has the 2 2's in it. The bottom one doesn't, so I need to multiply by a 2 and another 2. Now those factors are in common. What else do I need to do? Multiply the top one by a 3. Now they have a 3 in common. So this, of course, was 8 times 3 is 24. This, of course, is 6 times 2 times 2 is 24. 24 is the least common multiple of 8 and 6. And if you recall, we could do something like 12x to the third y and 8x squared y squared. 12 factors out to 2 times 2 times 3. X to the third is just x times x times x. And then we have the y. 8 is 2 times 2 times 2. X squared is x times x. Y squared is y times y. What do they have in common? A 2 and a second 2. You got it. They also have an x and a second x and a y. So this one up here has the extra 3 in the x. So I'm going to multiply by 3 and x down here. This one down here has the extra 2 and a y. So we multiply by 2 and y up here. So this, of course, is just our original number, the 12x to the third y. So 12 times 2 makes 24. X to the third and y times y is y squared. On bottom, this is our original number here, the 8x squared y squared. So 8 times 3 makes 24. X squared times x is x to the third, and nothing to multiply the y squared, so y squared. So 24x to the third y squared is our least common multiple. Look familiar? Covered it last week. Why are we so concerned about that? Well, because when we deal with fractions, we're going to talk about least common denominators. Before we move on to our fractions, there was a shortcut for this. If I looked at these, I could look at the numbers. The least common multiple for 12 and 8 is the 24. A lot of you can figure that out in your head or make lists if you have to. What was the shortcut for the variables? Of x to the third and x squared, I take the higher power. Good. X to the third is bigger, so it's x to the third. I have y and y squared. Y squared is the higher power, so I have y squared in my result. So let's say I have 15x to the 9th, y to the 5th, and 5x to the 4th, y to the 7th. For the numbers, 15 and 5, what's the least common multiple going to be? You're thinking, you're thinking factors. 5 goes into 15. One of the numbers can be the least common multiple. So 5 goes into 15. So for the numbers, 15 is the least common factor, or least common multiple, I should say. X to the 9 is going to be the larger of the powers. And y to the 7 is the larger power. So if I have 4, x to the 5, y to the 8th, z to the 3rd, 10, x to the 6th, y to the 6th, z to the 6th. I start out with my numbers, 4 and 10. What's the least common multiple? $20, good. If you didn't get that, of course, you could do 4 and 10. 4 is 2 times 2. 10 is 2 times 5. They have a 2 in common. This one needs to be multiplied by 5. This one needs to be multiplied by 2, which will give you the 20. X to the 6th is the larger of the two powers. Y to the 8, good. We had 6 and 8. 8 is bigger. Z to the 6th, good. We have 6 and 3. 6 is bigger, so z to the 6th. That's all there is to it. Well, in fractions, this process is very important. Back on the first day, we saw an example that was something like 1/3 plus 2/5. And we said we couldn't add those the way they were written because they have different names. And that's very true. So the first step in adding fractions is figuring out what name we have to change them to so that they are the same name. Now I'm going to write them vertically because that's how just adding makes more sense to me vertically. The least common denominator, or the name we're going to change them to, least common denominator, is just the LCM, least common multiple, of the denominators. So in this case, of 3 and 5. What's the least common multiple of 3 and 5? 15. Good. If I was going to factor those, neither one of them factor, do they? They have no factors, so it's just going to be multiplying them together. So what am I going to multiply the 3 by to turn it into a 15? 3 times 5. Good. So what do I have to do to the 1? Also times 5. So this is going to be 5/15. What do I multiply the 5 by to turn it into a 15? 3. So what do I have to do to the 2? Times 3. 2 times 3 is 6. And when I add, 5 plus 6 makes 11 over, does that become 30? Say no. When we add numbers, we combine the counts. So the 5 plus 6 made 11, but we keep the same name. So it's still 15ths. Remember, when we add numbers, we must have the same name. That's why we had to find common denominators. But then we keep the same name after we combine the counts. So if I have 3/8 plus 1/6, we're going to do the same thing. Least common denominator. Well, let's go ahead and factor these out. 2 times 2 times 2 for the 8. 2 times 3 for the 6. They have a 2 in common. What's the 8 need? 3, right? Then 3. And of course the 6 needs 2 more 2's. Multiply that out, you get 24 is our least common denominator. In fact, it even tells you, what did we multiply 8 by here? 3. 8 times 3 is 24. So 3 times 3 is 9. What did we multiply the 6 by? 4. 2 times 2 are 4. So 1 times 4 is 4. 9 plus 4 is 13. 24th, keeping the same name. How about 7/12 plus 3/8? Common denominator. I could factor them out. 2 times 2 times 3, 2 times 2 times 2. What's it going to be? They both have 2 2's in common. This one needs what? 2. This one needs a 3. So if I multiply those out, I get 24 is my common denominator. What does 12 have to be multiplied by to turn it into a 24? 2. Yeah, you're thinking of the 8. So that's 7 times 2 is 14. What's this going to become up here? 9. Good. 8 times 3 makes 24, so 3 times 3 makes 9. And we add. 14 plus 9 makes 23 24ths. In your notes, try to add for me 1/4 plus 3/10. What's my common denominator? 20. What's going to go up here? 5. Good. 4 times 5 to make 20, so 1 times 5 is 5. What's going to go up here? 6. 10 times 2 makes 20, so 3 times 2 makes 6. So then I add 5 and 6 make 11 over 20. How many of you had 11 20ths? Good deal. So what if we end up with something like this? 7/8 plus 7/10. First, I want you in your notes to find the common denominator for me. Figure out what that common denominator is going to be. What'd you get? 40. Very good. So this up here is going to become 8 times 5 makes 40, so 7 times 5 is 35. What's this become? 28. Good. 10 times 4 makes 40, so 7 times 4 makes 28. Then what? We add 35 and 28 make 63 over 40. Now we could leave it like that, but we normally wouldn't. Why not? Because right now the numerator is bigger than the denominator. It's an improper fraction. Normally we would change it to 1 and 23 40ths. Good. Taking out the 1 would take out 40 pieces out of the 63, leaves us with 23 left over. 1 and 23 40ths as a mixed number. In your notes, I want you to do 5/8 plus 3/4 quick for me. Find the common denominators and add and reduce or split into a mixed number if necessary. What's my common denominator going to be? You could use 16, but 8 works. Remember, it's always possible for one of the denominators to be the least common multiple. So this will stay 5/8 because we didn't change the 8. This is going to become 6. Good. 4 times 2, so 3 times 2 is 6. Then we add 5 plus 6 is 11/8, which reduces to 1 3/8. If you had used 16, it would not be wrong. If you did 16, this would become 10/16. This would become 12/16. We would add to get 22/16, which would split into 1 6/16. The 6/16 reduces to 3/8, so it'd still be 1 3/8. It's just a little more work. If you don't have to find the least common denominator, it'll still work with a larger common denominator. It's just a little more work. First, you have to work with larger numbers, and then second, when you get done, you have to reduce. So you have to make sure you reduce the 6/16 to 3/8. So how about 3/4 minus 1/6? What's my common denominator going to be for 4 and 6? $12. Very good. So this will become what? 4 times 3 makes 12, so 3 times 3 is 9. This is going to become 2. Good. 6 times 2, so 1 times 2. And now we are subtracting. So 9 minus 2 is 7, and we still keep the same name. So 7/12. So let's have you do, in your notes, try 5/8 minus 2/5. What's my common denominator going to be? 40. What's this numerator going to become? 8 times 5, so 5 times 5 is 25. Good. This one will be 16. Good. 5 times 8 to make 40. 2 times 8 is 16. And then we subtract. We subtract numerators. 25 minus 16 is 9, and we keep the same name. We keep the common denominator of 40. Not so bad? Okay. That's where we're going now. Yep. Good thing you asked. Or bad thing, depending on what your point of view is. Bad thing? It only hurts for a little while. So, we can have something like this. 5 over 6x squared, 3 over 8x. Now this is why we spent so much time looking at those least common multiples. I'm going to write these out over here. My 6x squared and my 8x. If I factor the 6x squared, it's 2 times 3. Then the x squared I'm not going to worry about. Well, let's do it. We can write it out. X times x. 8 is 2 times 2 times 2 times x. In common, they have a 2 and they have an x. What's the top number need to have? 2 more 2's, right? Which is the same as multiplying by 4, right? This becomes 20 over 24x squared. What's the bottom one need? 3 and an x. Notice what I'm multiplying by over here is the same thing I had to multiply by here to get my common multiple. So I multiplied this by 3x over here. 8x times 3x is 24x squared. I also multiply the top by the same thing. 3 times 3x is 9x. Now I have a common denominator, so I can add. The issue is, what's 20 plus 9x? It's 20 plus 9x. I can't combine those any further. Over 24x squared. So I get that. Does that mean if there's variables involved, I'm never going to be able to combine the numerators? Not necessarily. I could have three over 4x plus 2 over 5x. If I look at my 4x and 5x, I don't need to list this out. What's the common denominator between the numbers 4 and 5? Least common multiple will be 20. For the variable, well, they're both x, so the highest power is just 1, or just x. So 20x is my common denominator, least common denominator. 4x had to be multiplied by, well, 4 times 5 is 20. I didn't have to change the x. It's just 5. So 3 times 5 is 15. What did 5x have to be multiplied by? 4. So 2 times 4 makes 8. So here I can combine the numerators. 15 plus 8 is just 23 over 20x. A lot of you will look at that and you will be very, very tempted to say, oh, that's 23 over 20. I got to make that into a mixed number. When there are variables involved, when there's variables in the fraction, we can never turn it into a mixed number because we don't know what the value of that variable is. This is 20 times x here. X could be 4, 5, 7. It could be any value. So this might actually be a proper fraction. That denominator could be bigger than the numerator. So because we don't know the value of those variables, we can never turn a fraction with variables in it into a mixed number. It'll always stay an improper fraction. So let's see here. So 5y over 12x plus 3 over 8x to the third. For our numbers, 12 and 8, can anybody tell me what the least common multiple or least common denominator will be? 24, good. For the variables, I have x and x to the third. My least common multiple there will be the larger power. So x to the third. So up here, did I have to change the number? Yeah, 12 became 24, so I multiplied by what? What did I multiply 12 by to make it 24? 2. Did I have to change the variable? Yeah, I went from x to the third, so I have to multiply by x squared. So the top here is multiplied by 2x squared. 5 times 2 is 10. Y times x squared is x squared y. You might ask, could it be yx squared? Yeah, that's fine, but it's just more proper grammar to have them in alphabetical order. So x squared y. Down here. See if you got it? Okay. No problem. Down here, did I have to change the 8? Yeah, to make the 8 into a 24, I had to multiply by 3. Do I have to change the power of the x? No, I got x to the third and x to the third, so I don't have to change that at all. So I'm just multiplying by 3. So 3 times 3 makes 9. Now on this one, when I add, I'm going to combine the counts, combine the numerators. 10x squared y plus 9 is just going to be 10x squared y plus 9 over 24x to the third.
Yep, I'm done.
You've had enough?
Yep.
Let's make you try one on your own. X over 4y squared plus 5 over 6y. Try that one in your notes, see what you come up with. We'll talk about it in a couple minutes. So for the common denominator, 4 and 6, the least common multiple is 12. For the y's, it's going to be y squared is the larger power. So this one had to be multiplied. 4 has to be multiplied by 3 to make 12. Do I have to do anything to the y? No, it's y squared and y squared, so nothing changes there. X times 3 is just 3x. What has to happen to the 6 to turn it into a 12? Times 2. Does anything have to change with the y? It has to go from y to y squared, so we multiply by just y. Y times y makes y squared. So 5 times 2y is 10y. So now on top, we've got to add the numerators. 3x plus 10y is 3x plus 10y over 12y squared.
So why does it change from y? How come 6y times 2y isn't?
Because this is 6y here, so I'd turn it into a y squared, so I'd multiply by another y. Yep. Good question. So how about 4 over 5x minus 3 over 10x squared? My common denominator for 5 and 10 is going to be what? 10. Good. Least common multiple between 5 and 10 is just 10. How about for the x? X squared. Good. So what do we have to do to the 5? Times 2. Did we have to change the variable there? Yes. So to turn x into x squared, we multiply by another x. So we multiply by 2x on bottom. Multiply by 2x on top. What is 4 times 2x? 8x. Good. Down here, what do we have to do to the 10x squared? Nothing. So this just stays a 3. The only difference between this and what we were doing before is this is now subtraction. So instead of, when we combine our 8x and our 3, it's 8x minus 3 over 10x squared. What do you think? Better than a sharp stick in the eye? Mildly? Okay. So have you try one? (7x) or 7y over 12x minus 5 over 8x squared. Try that in your notes, see what you come up with. So, common denominator will be x squared for the variable, yep. How about for the number, for 12 and 18? 24. Good. Obviously, we changed 12 to 24. We're multiplied by what? Times 2, and we have to change the x to x squared, so we have to multiply by x. So 7y is also multiplied by 2x to give us 7 times 2 is 14. Y times x becomes xy. Again, yx is fine, but it's better to put them in alphabetical order. 8x squared, what do we have to do? 8 times 3 to make 24. X does not change. So we just multiply by 3 on top. 5 times 3 is 15. 14xy minus 15 is 14xy minus 15 over 24x squared. How many of you had that? Good deal. Well, we're 2 minutes early, but I think we're good to take our break here. So let's take our break. Let's come back at about 4:28, and we'll start up with the second